In this lecture, we'll explore the attention architecture used in transformers. This model is entirely based on attention mechanisms without relying on recurrent layers, which makes it highly efficient and allows parallel training. That scalability is one of the main reasons transformers became so powerful. When we provide an input sentence to the transformer for translation or any language task, it passes through two main components, the encoder and the decoder, both of which use attention mechanisms. Let's begin with the encoder. The encoder takes the input sentence and first converts it into context embeddings. These embeddings capture the meaning of the words in numerical form. The data then moves into the self-attention layer, which helps the model understand how each word relates to every other word in the same sentence. For example, in the sentence, "I love llama," the model learns that I and love are strongly connected, while llama is less related to I. The self-attention mechanism computes these relationships, producing encoded values that represent contextual meaning. These encoded values are then passed through a neural network for further processing. Next comes the decoder, which operates slightly differently. The decoder includes a masked self-attention layer that predicts the next word in a sequence. Imagine the model has already generated the words, "I love." Using masked self-attention, it focuses only on the words that have already been produced to predict the next one, without looking ahead at future words. This masking ensures the model generates text sequentially, just as humans do. The decoder also includes an encoder-decoder attention layer. Here, the decoder uses information from both the previously generated words and the encoder's output to make more accurate predictions. For example, it takes the encoder's representation of "I love llama" and combines it with the partial output "I love" to predict what comes next. This combination of self-attention, masked self-attention, and encoder-decoder attention allows transformers to understand context deeply and generate coherent, context-aware outputs. That's the core of how the encoder-decoder transformer architecture functions. In the next lecture, we'll discuss other transformer-based models such as GPT to see how they build on these principles.